I'm audible.
Yes, sir.
Is it visible? Screen is visible.
Yes, sir.
Okay. So today we will start discussing about how a powerful, flexible, full-fledged keyboard can be interfaced to the microcontrollers. In the last few classes, we have designed about how we can able to interface LEDs, single switches, and the 7-segment display to the system. Whenever you want to build any project, a full-fledged project, basically it's very essential to give a powerful keyboard to your product, because there is a requirement for you to feed the complete number. For example, you're building a system, a smart system where you want to feed a key code into your system. In such cases, what you have to do is you have to press a code 1, 2, 3, 4, 5 and enter, or sometimes the alphabets also can be part of the code. So that means that any full-fledged smart system will require a key code or some characters to be input to the system to log into the system or to select the different modes of operation for the system. We will see that today how a product can be given a full-fledged keyboard so to the system. What is the drawbacks of connecting the single keys? How do we overcome that? And how do we write the complete driver program for the keyboard? So this driver program, what we are writing today, is that same driver program is present in your Windows operating system or the Linux operating system also. The way they interface the keyboards or something in any of the sophisticated system, the same program is being used. So what the program we are discussing is an industrial grade program. In the sense, the same program has been used in many industrial products. I'm audible?
Yes, sir.
Yeah. Okay. So let's think about one key that we already learned and interfaced to the microcontroller. Let's say I've interfaced one key to the microcontroller P1.19. We know that whenever the key is not pressed, we should make sure that the logic is not unstable. So that means that any of the pins, if you're using for your project, the input pin should be stable. So what is the meaning that I mean when I say stable? So when I say stable, that is at this point, whatever I'm using it. So this point should able to give me a perfect voltage when I read from a microcontroller. Either it should give a 1 or 0. So that means it should be stable. It's not like sometimes 1, sometimes 0, without my knowledge, without the expected way. So then it's called unstable. So how do we produce that expected value here? That is where we use a pull-up resistor. That means that when I am not pressing the key, if I don't use the pull-up resistor, the line is just floating. The wire is floating. It can pick up the noise from anywhere in the surroundings, so that the value what you read can be not the true value. Sometimes 0, sometimes 1. It depends upon the noise. To make sure that it's always stable, I'll connect through a resistor of 4.7K or around 10K resistor to the voltage of 5 volts. So whenever I pull up like this, the voltage at this point is confirmed. That is, I'm receiving 1 if I'm not press the key. When I press the key, what will happen? I'm shorting this wire. I'm pulling this point to the ground so that I'm getting a 0. So this is the arrangement generally we make whenever key is connected to any of the microcontroller. Whenever the microcontroller pins are internally pulled up, then there is no requirement of using external pull-up resistor. That you have to make sure, and then only you have to leave the pull-up resistor. Now, how many pins are required to connect one key here? If you observe here, one port pin is required for one key. Let's say I required a 16 key for a good keyboard where you can feed all the numbers 0 to 9, and there's an enter key, there's a backspace key, the selecting certain functions. You require at least 16 keys for a sophisticated keyboard. So if I want to interface 16 keys, then you look at that, how many pins are required? 16 pins are required. That means that among the 45 GPIO pins, what is available for a microcontroller, for example, LPC2148, you are wasting at least so many pins only for the keyboard. Now the question comes, is there any other way? Is there any other way I can reduce the number of pins required from the microcontroller to interface the more number of keys? So this question has driven the interfacing engineers and the programmers to think on this line. That means that, can I reduce the number of pins required from the microcontroller to interface more number of pins? That is, more number of keys. Keys are more, but can I reduce the number of pins? Normally, what we require, one key, one pin is required. Now, what is my requirement? Keys are more, the pin should be less. So this has given rise to a concept called as matrix arrangement of the keys. So how does a matrix arrangement? I'll just show you for one. Let's say I will place these keys one after the other. Let's say I place this one. So I place another one. So then I place another one here. So now let's say I have arranged this in a one row, 4 keys one by one. So what I have done now here, so I have arranged the 4 keys. Now one by one I have arranged it. Now I will take another 4 keys. So I will place them below that 4 keys. Let's say one arrangement. Now look at here. Now what I have done, so I have placed one row. I'll call this as a row. I'll call this a row because multiple things are there in a single line. 4 keys I have placed. In the second row I have placed another 4 keys. I have placed it. Like this I can able to arrange. In a given line, I need not have always 4. I can have 2, 6, 8, anything possibilities there. Now I have taken an arrangement of 16 keys. Since I said 16 keys are very commonly used in the projects, I take an arrangement of 16 keys. So now, how many keys are there? So 16 keys I have taken. Now all these keys I have arranged in the rows and columns. Only logically, I still have not connected. Logically, I place them in the rows and columns. Now, effectively, if I use a normal interfacing technique, 16 lines are required from the microcontroller. Now I will reduce as many lines as possible from the microcontroller side. For that, I'll make an arrangement. So what is the arrangement? I'll make it. Now, all these columns which are there, I'll call this as a column. I'll call this as a rows now. So in each row, there are 4 keys are there. In each column also, 4 keys are there. This arrangement can be anything. It need not be square. You can have 2 cross 4. You can have a 4 cross 6. You can have 8 cross 6. Any combination is possible. I've just taken a 4 cross 4. Now what I'll do is, now I will take this columns of first column, all the 4 keys. I will join them now. I'll join them in a wire, using a wire. So I will join them. So I will join all the wire. So and just pull that wire down. So now what will happen? So now I have one column is ready. That is one wire is ready, which is shorted the one pin of all the keys present in the first column. Similarly, what I'll do is now I will join one pin of all the keys present in the second column, second column. So I got second column ready. Now similarly, I join one pin of all the keys present in the third column. Similarly, I will join one pin of all the keys present in the fourth column. So now I have 4 columns is ready. Now what I will do is, I will join another pin which is I have not used of all the keys present in the row and make one line. I'll make one line. So now what I'll do, let's say I'll take green color. I will just drag that line. I place it here. Let's say that. Now, so look at here. That is, I have not made any connection. I just taken a wire now. To make the connection, what I'll do is I'll just put it here. So I'll put this here. I'll put this here. I'll put here. So what I did, I have selected another left out pin of all the switches in the first row, and I have connected to one single line. I'll call that as a row. The one row, I'll call this a row. These are the columns, I'll call this a row. Similarly, what I'll do is similar method, I'll follow the other one. I'll not show the connection, I'll just make the line, keep the line there. So I'll just keep one there, second line, okay. I'll just make one connection. Similarly, other connections are there. So I'll make one more line and connect the left out pins of the keys present in the third row. So similarly, I will make one more row, so which is formed from the keys present in the fourth row, and I connect all the left out pins of the keys present there. So like this, I would have connected there. Okay, so now my connection is ready. Now look at the possibility of this keys now. So since I have connected all the keys to the corresponding the rows and column, every key, two terminals is connected to one row and the one column. For example, if you look at, let's say I want to give a numbering for that. So what is the numbering I can give it? Since it is 16 keys are there, let's say I use key numbers called 0, I'll call it as. So I will call the keys, so by numbers. So let's say this is a 0th key. So I'll call this as a second key. Similarly, I'll call this as a third key. So I'll call this as a fourth key. So similarly, what I'll do is I'll give a key number for this also. Let's say this will be the 5. So this key will be the 6, and this will be the 7, and this will be 8. There is no requirement that you have to give the same numbering. Using what is called as lookup tables in the program in the later, I can change these keys into whatever the keys you require. For example, key A, I can call as a key called star. The key called C, I can call as alpha, some alphabet called any other alphabet, or I can use that key as a backspace key. For example, I'm using a key E. So 0, actually I should have started with 1, 2, 3. So I just change that number. Okay, so let's say this will be the 0th key. So 1, 2, 3. As I was telling you, these keys need not to be the same thing. It is the design engineer who designs the product who takes the decision. For example, design engineer does not require keys like this. He wants some other meaning for every key. He can give the naming. The names for the keys will be decided not by the programmer. It is decided by the product engineer. So for example, the product engineer requires 0 to 9 keys only. He does not require hexadecimal A to F. He will not give the keys. He will give only up to 9. He will use the remaining keys for something else. For example, enter key, backspace, clear, F1, F2, like that. That means that the keys numbering or the naming of the keys depends upon the interfacing engineer or the person who develops the product. Now, to make it simple for this experiment, what we are going to do now to build a program to interface a matrix keyboard, I'm just given these namings. So always remember that anything can be possible. So what is the flexibility? The matrix size can be anything, 2 cross 4, 4 cross 6, anything. The naming of the keys also can be anything. Now, I will call these as the rows. So these are the rows. Now, how many rows are there? So you can see that there are, so this is a row 0. I'll call this as a row 0. So similarly, it will be row 1. So it will be the row 2. I'll call this as, and this I'll call as a row 3. Now, these are the columns. I'll call them as a columns. So the column namings can be anyway. I have given like this. So I'll call this as a 0 key column. So then I'll call this as, so 1, column 1. I'll call this as a column 1. So then I'll call this as column 2. So then I'll call this as a column 3. Okay. So now I have a 4 rows are there, 0, 2, 1, 2, 3, and they have a 4 columns, 0, 1, 2, 3 as available. Now I have placed the keys in a particular arrangement. Okay. Now, why I have placed like this? What is the purpose of placing like this? If you just observe for a moment, this matrix keyboard, whatever I have written, it has come out. When you look at this matrix keyboard, you can see that the outside of this keyboard is basically consists of what? 4 rows are there, and then 4 columns are there. That means that the outside keyboard has got 4 rows and the 4 columns. That means that the external world, which is an external world, the microcontroller can talk to the keyboard using this what is called as the 4 rows and the 4 columns. Now, how many pins are required to talk to this keyboard from the microcontroller? The 4 rows are there. That is 4 lines here, and the 4 columns are there. That is 4 lines are there. 4 plus 4, 8. Normally, how many are required? Since 16 keys are there, 16 lines are required. Now, how many I have reduced? I have reduced 8. This is a great saving in terms of the microcontroller pins. Only 8 pins I'm going to use now to connect this keyboard to the microcontroller now. So now what I'll do is, so now since I've arranged them in a particular arrangement, so there is no requirement for me so to see connecting a single keys like this. Now look at the possibility now. What is the way we have to develop the interfacing for this keyboard now and the program now? So let us observe one key. Let us take one key to start with here now. Let's assume that one key now. Now, this key, whatever I'm talking now, when I'm not press the key, correct now, what is the change it produces? Because this key is connected to 2 points. One end is connected to the row, other end is connected to what column? That means that this key press or release is communicated to the external world, that is a microcontroller, either through what line? To the row line or to the column line. Now we have to make an assumption. So which is the line you're going to use? Either this line, row line you're going to use to communicate to the microcontroller, or you're going to use a column line to communicate to the microcontroller. Let us assume that I'm using column line to communicate to the microcontroller. Now, how do you communicate? We know that always it should be stable. What do you mean by stable? When the key is not pressed, you should carry some voltage here. When the key is pressed, you should carry some voltage here. That is a different voltage you're supposed to get it here. That means that I'm observing at this point here now. What is the voltage at this point now? So this point, whatever I'm observing now. So this is the point where I am making an observation. Okay. Okay, let's say this is the place where I'm observing my data here. This is the place I am observing the data here. Now, if I don't press a key, I supposed to get always here what? 1. Otherwise, what line will be floating? See that this line is floating. So what I will do is I will take this type of resistor, pull up resistors. Yes or no? So I will copy that. I will place it here. That is every column now should be given to pull up resistor. So now what I'll do is, so every line, so whatever the line I have here should be connected to the pull up resistor. So now I'll not show the just resistor. I'll just put this line here. So what will happen? All these points which are there from here onwards, I'll just take that lines. Okay. So I will connect all them to a pull-up resistors. So I'll connect them all them to the pull-up resistors. So individually it can be connected or it can be connected so together also. I've just connected them to the pull-up resistors. So what I've done, they have connected to the plus 5 volts, plus 5 volts. So using the pull-up resistors, using the pull-up resistors. Okay. So now what I've done, I've connected all the columns to the pull-up resistor to the 5 volts. So to the 5 volts using the pull-up resistor. So one resistor will be here, one resistor will be here, here, and here will be there. Now, if I don't press the key, what is the value I'm going to get here in this column is the 0 voltage I'm going to get it. So that means that I'm going to get the 0 at this point. When the key is not pressed, I'm going to get a 0 voltage now. Now, let's say now I'm going to press the key here. When I press the key, what will happen here? That means that there is a change at the column. There is a change at the column, which the key is connected. It happens only depends upon what value is present at the row. That means that let's say when I get shorted here, what will happen? The row and the column get shorted. See that the one end of the keyboard is connected to what? The column. The other end of the key is connected to what? The row. Whenever I short this key, when I press this key, what will happen? The row and the column get shorted. So whenever they get shorted, what will happen? The voltage you get at this point depends upon what voltage is present at the row. Since when I don't press it, what is the voltage I'm getting? I'm getting always high. When I don't press anything, I'm getting always what? High. So that means that one is means what? One means so key is not pressed. No key is pressed. That means that no key is pressed. Now, whenever I press the key, I should get opposite of this one. That means that the row should be given opposite of the voltage which is supposed to be given for the column. Column is by default to be given high, that is 1. So I should give what? Row opposite. So that means that, so I will get either 1 or 0 on this column. So when do I get that one change? When I apply the 0 at this point. That means that, so I am applying what? 0 here. So applying the 0 on the first row, whenever the key is pressed, I can see a change in the column 0. This is the technique. Now what I'll do is, now I'll go to the second key now. Now, when I read the column, second key is connected to what? Second column. That is, let's say if I call column 0, column 1, I can see a change on the column 1 whenever the key is pressed here. Because why? The row is applied what? 0 voltage. So that I can see a change here. Similarly for the third column, third and the second column. So whenever the key is pressed, second key, I can see a change here. Whenever the third key is pressed, I can see a change here. That means that any of these columns will get 0 voltage if the corresponding keys is pressed in the corresponding row. So which is the row? Now we are attending the first row. So to identify the key press, am I audible? Am I audible?
Yes.
Yes, sir.
Yes.
Yes. Okay. So that means that key press in the first row can be identified by looking at the columns. That means that I should keep on looking on a microcontroller. What is I should see? Using the microcontroller, I should keep on looking at the columns. Generally, if I don't key press, 1, 1 will be there. Any of the keys pressed in the first row, 0, 1, 2, 3, in the corresponding columns, you get what? 0. So that means that you can identify a key press in the first row. So by using this logic. So now we got an idea for the first row. Now, let's say that if the user press the key in the second row, then what should I do it? Since these 4 columns or only 4 columns are there, I can use these 4 columns either to read what? Keys of the first row or keys of the second row or keys of the third row or fourth row. That's all. I cannot use the same columns to read the keys of the 2 rows at the same time. Let's say now one example, we'll take it. Let's say the key 0 is also pressed, key 4 is also pressed. Assume that I've applied the 0 to the row 1 also. Then what will happen if both the keys are pressed? Then I'll get what here? The change from 1 to 0 I'll observe in the column 0. But whenever the change I get a 0 in the column 0, that means that key is pressed. Which key is pressed? Either the 0 would have been pressed also or the 4 also would have been pressed. That means that whenever there is a 1 column is there, see I have got only 1 column 0. This column 0 reflects the information from one of the 4 keys. What are the 4 keys? 0, 4, 8, and C. All these 4 keys do have only one line to convey the information. Yes or no? So that means that these 4 keys convey the information of press through only one line. But since how do I identify which key is pressed? Because anyone could have been pressed. It is difficult. That is why through the program we are using some logic and interfacing circuit, and the program is to be used collectively together to get the idea that whether I have got information about the key 0 or 4, 8 or C, how it is possible. Now this is the technique. What I'll do, first I will apply the 0 to the first row, then I'll read the column 0. I'll check if it is 0, that means that what, the key 0 is pressed. Then what I'll do to identify whether this key is pressed or not, I will remove this one. I will move this point from here to here. So what I did, I applied first 0 to the first row. Now I remove the 0 here. When I remove 0, what does it mean? That 1 is there here. So that means I made 1 here. Now I apply the 0 to the second row. Now I'll read the here. Now if I get a 0 here, what does it mean? That key 4 is pressed, not the 0, because I am applying 0 through the programming. As a programmer, I know that I am checking the 4th key. Now no key is pressed. Then what I'll do is, now I'll move this 0, that is applying the 0 to what? So I will go this to the next position. So I will make this, I will make to move to this position, second row. Now I will observe whether the 8th key is pressed or not by observing a change here. No key is pressed. Now what I'll do is, I'll move this to the 3rd row. Check any key is pressed. If the change is there, so that means that C is pressed. Same logic I follow for all the other columns also. Then, so this is the way we have to interface and matrix keyboard to the microcontroller. Now, summarizing, what do I require? I have to select or apply 0 to any one of the 4 rows only. Once I apply the 0 to the one row, check any key is pressed in that row. If no key, then shift the application of the 0 to the next row and next row like that. So for that mean that I am generating output from the microcontroller to the rows. That means that I am making 1 and the selected row as what, 0. That is, I am generating the data to the rows. That is why the rows are called as output to the microcontroller. Now what I am doing with the columns, I am reading the data from the columns. With which, why I have to read? I have to check whether the data has changed, whether any of the column has become 1 from 1 to 0. That means that I am checking the key press. I am reading the data. So that is why. So it is called as what? It is called as inputs to the microcontroller. See that till this experiment, we have most of the experiments we have used microcontroller pins as output. In 7 segment, all the pins were output. In stepper motor, all the pins are output. So this is the first experiment where we are using some pins for what? Output, some pins for what? Input. Now the columns are always as what? Input to the microcontroller. The rows is always what? So output to the microcontroller. So now we will start developing an algorithm or a program for this interfacing for this keyboard. Now, so what are the things I require to develop the program for this one? Now I should choose 4 pins of the microcontroller to connect the 4 rows. I have to choose the 4 pins of the microcontroller to connect to the columns. So what we do, we will select P0.16, 17, 18, 19 that we have already selected for a stepper motor. Those same pins we use here for output to the output as a microcontroller and input to the keyboard. So we will select P1.16, 17, 18, 19. I'm using port 1 now. Now port 0, 16, 17, 18, 19 I was using port 1, 16, 17, 18, 19 for the columns. I'll use it. Now, so what I will do is I will start developing the program for this one. So what is my thing? So this is port 0. So 16, 17, 18 and the 19 I've used here. So here I'm using so P1.19 for the column 0, 18 for the column 1, 17 for the column 2, 17 for the column 2, and the 16 for the column 3. So I've used like this. So here 16 is the for the rows. So I have made an assumption now. So now we will start developing the program. So we will go to the program now. Now, what are the things required to develop this program is required now? Now, first of all, I should able to number the pins. So what I'll do is I'll copy only that portions what is required so that easy for you to follow. So now I will. So now look at here. I have just done columns. So what I've done, I given a names for the columns. Column 0, 1, 2, 3. Column 0 is what? 19. Column 1 is 18. Column 2 is 17. And the column 3 is equal to 16. That means that why I have done like this means, so whenever I want to read the column 0, we know that what is the instruction we have to use to read the data from any pin. So the pin is the register is available to read the data at any of the pin. Since a port 1 is used, so I have to use instead of 0, I use what? IO1 pin, I'm using it. Yes or no? Now, which is the pin I'm interested to read? I'm interested to read the 19th pin. That is why we are creating a 32-bit pattern where, so only the 19th pin will be the 1, remaining pins are 0. So I'm ANDing that with the IO pin. So effectively, what does this value we use column 0? Whenever I read column 0 in the program, either it gives me what? 0 or 1 it gives me. That is a true, either 0 or non-zero value it gives it. So that is why, so I have written this one. So column 0, column 1, column 2, 3 means what? Either it gives me 0 or non-zero. So whenever it gives a 0, that means that what key is pressed. Whenever it gives 1, that means that key is not pressed. So I have defined now 4 columns so that I can check columns are there or not now. Now, I will start my program now. So how do we start it now? So first I have to enable the first row and then check any of the keys pressed in the first row. So that is my logic. So now I'll go to the program. So I will just select the first row. Now I'll select the first row. So now look at the logic here. Now what is my logic here? I am selecting the first row. So how do you select the first row? I declare one variable. So I can declare one variable, let's say unsigned character. So let's say row select. So it's a one variable I given it. So what is I making? Since I'm testing the first row, I require a variable to know that in the program which is the row I'm selecting. That is why I'm making the row select is 0. That means that what? I'm selecting the first row. How do you select the first row? You have to send 0 to the row pin. We have seen that. What is that we have to do it? I have to send the 0. I have to send the 0 to row 0, or I have to apply it. So how do you do it in the program? So I have to use, first I will set all the pins to 1, 1. That means that is a set register. Because why? I used F here. Just look at here. So the F is placed at the position what? 16, 17, 18, and the 19. So I'm making all the rows first 1, because I said whichever the row you are not using, always you have to apply what? 1, 1, 1. So since these pins 16, 17, 18, 19, all the pins I'll make it 1, 1, 1 in the beginning. How do I make it 1? I'll apply the F. That is because 16, 17, 18, 19 corresponds to what? 1 digit. I'll apply the F to that particular position. So I will write this value. So whenever I write this value, what will happen is the 4 bits corresponding to this digit 16, 17, 18, 19 becomes 1 because I applied to set register. Now, after making it 1, I should make only one row 0. So which is a register we can use? Clear register is a 1 which can use, we can make it 0. So which is a bit I'm interested? 16, because P016 is the first row. So row 0, that means that I'll apply that. So this statement enables all the rows, other rows except the row 0 becomes 1, only the row 0 becomes a 0. And I will enable one variable called row select is 0 for the programmer to identify which is the row I am in operation. Now it's ready. Now what should I do it? Since I've enabled the row now, check for any of the key is pressed, any of the key is pressed now. How do you check it? Now already I've declared a variable column 0, column 1 like that. I'll just take that variable now for a moment. So now what I'll do is I will select that variable. I'll put those variables here. So look at here, what I have done here. Now, So I will also select one more variable called column select. I'll declare column select. I'll declare one more variable called column select. I'll declare it now. Now look at here now. So what is it I have done now here? So I am going to put this whole logic. I am going to put this whole logic inside a loop. So what is I am doing? After the row is enabled, the first row is selected, I am going to check whether the column 0, that means that what? The pin P1.19 is 0 or not. We know that. What does it mean? That whenever it gets 0, that key is pressed. That means that this statement, if it's satisfied, that means that you press the first key. So whenever the key 0 is pressed, that means that column 0 becomes what? 0. Instead of 1, it becomes a 0. So that means that I'm checking whether this key is pressed now in the program. So if it is true, if it is 0, then what I'll do, I'll make one variable, column select variable is equal to 0. Already I made the row select is equal to 0. I'll make this variable explicitly in the programming 0. Now I'll come out of the whole loop because my job is done. So what is the program I'm writing? The whole program I'm writing is what? Any one key is pressed in the matrix keyboard, come out of the program and just print the key pressed. That's all on the program I'm writing. So that the whole logic what I'm writing here, I can put that logic in a do while loop. So what I can do is I can just put the whole logic in the do while loop. So I just placed it do while loop. So what I'm doing is the moment I check this, any of this column is pressed, either column 0, column 1, column 2, column 3, I will set the column select variable appropriately. If the second column is, if the first column, in the sense 0th column, this is, if the first column is 0, that means that key 1 is pressed. So I am checking each of these keys is pressed, set the column select variable to what? Either 0 or 1 or 2 or 3 and come out of the loop. So when I come out of the loop, so there are two variables are there for me. What are the variables? One is a row select variable, other is a column select variable. These two variables gives me an idea that, so which is the key pressed, then take an appropriate action. That means that, so print, so once it is done, then what I'll do is, so print the key. So I am doing here, identify the key pressed, either the key 0, 1, 2, 3. If it is pressed, you come out of the loop, then what? You print the key. So where do you print the key? Maybe outside after the while loop, you print it. So this is what we are supposed to do it actually in the program. Now, if the key is not pressed, then what I'll do, I'll be keeping looping. Because why? How do you call scan keyboard? See, this is basically the code present inside the scan keyboard. Whenever in the C language, you use the, so scanf. What does a scanf will do? It will wait for a key press. The moment it will wait, you press a key, then only it will come out. Otherwise, what? It's an indefinite loop. Same way here. So the whole program, what you written here, it's called scanf. It will be scanning for the key. The moment you press, it just comes out of the loop and gives me the key. In this case, what? The row select and the column select gives an idea which key is pressed. Now, let's say if the first row is not pressed, no user has not pressed any of the key. So then what should I do it? I will copy the same logic, yes or no, and try for the second row is pressed or not. What are the changes I do it? Row select, because I'm checking for the second row, I'll make it 1, and I am, instead of 16, I'm making 17. Because why? The row, first row I checked, I'm going for the next row. I finished it. Now, let's say if the no key is pressed in this one. So what I'll do is, I'll copy everything. I will go now for this next one. So what I'll do is now, next is what? So I will make the row select is equal to what? The 2 now. So row 0 is finished, 1 is finished, row 2. So now since you're checking the row 2, enable only that row. That is, make it only that row is equal to 0. All other things become what? 1. Let's say no key is pressed here. Then what should I do it? Check that one. So since it's not pressed, so now go back to the next row. Go back to the next row. Now I finished. Now my program is ready. So what I'm doing is, I am checking all the rows one after the other if the key is pressed. If no key is pressed in a particular, go to the next one. Keep on do this one until you come out of this loop. So this is the logic what is required to identify whether the key is pressed in the matrix keyboard or not. Am I audible?
Yes, sir.
Yeah. So now, so we have identified now, finished one logic now. So we have used the 4 rows, the 4 columns. We have developed a driver program to scan through this keyboard. Now there are certain technical aspects there whenever the keyboard is interfaced. This is where the knowledge of hardware is also required. When you press this key, most of the keys what you've seen in any of the embedded products, they are all mechanical keys. That means that moment you press that key, there is what is called some bouncing action will happen. How does a bouncing action look for that? For example, if you press a key, so you can see that this action will be there. That means that it will not reach immediately 0. Since the key is bouncing, you know that mechanical keys, what will happen when you press, the small bouncing happens. See that it will take some time and then it comes back to what? Logic 0. That means that 1 at the column becomes 0 after what? This oscillation. This is called bouncing effect of the mechanical keys. If you read, what will happen? There is no guarantee that you are getting 0 or 1. So that means that wrong key you may get it, or sometimes if you press one key, you may get a multiple keys. Many times you have seen in some of the PCs, there's a problem is there. If you press A one time, you get a 4 A's, you will get it because of this reason only. Because you're reading so fast, that means that you will get what? Many keys pressed. That meaning is that. So that means that you have to avoid this area. What is this area? Is called bouncing area. So to avoid this area, what is the method? It has been identified by many of the programmers, by many of the interfacing engineers. Giving around 20 millisecond gap will make sure that means your system will be perfect. That means that as soon as you identify a key, give some time before reading for the next key. So this allows you for what? That bouncing can be avoided. So actually what we have to do in the program, we should allow some bouncing, we should allow some time, 20 milliseconds. Again, we have to read it. But in the program, to simplify the program, I'm just giving one time 20 milliseconds. So now what I'm doing in the program, after this, immediately after this, I have to give what is called as debouncing action. So what is a debouncing action? Giving some time for the key to complete the bouncing action before I go for the reading for the other key. So debouncing of the key. How do I do it? I can do it. Delay seconds, I can give it. Here I just 20 milliseconds. 20 milliseconds is good enough. Now, so now we have finished the debouncing action. Now, can I go for reading the next key immediately, or be using this function, using this program again? No, not possible. There's one more issue is there. So what is that issue? That whenever you press the key, now you've taken care of the bouncing. Before I call the scan keyboard again to read the keyboard, another key, make sure that the previously pressed key should be released. Unless I release the previously pressed key, correct now. Again, if you read it, what will happen? You will get a multiple times the same keyboard. If you press one time 0, you get at least 4, 5 zeros, you'll get it. So what is the next action I'm supposed to do in the program? Wait for the release of the previous key. So what should I do? Wait for the release of the previous key. So how do you do it? So how do you do that? We know that whenever the key is pressed, what will happen? One of the column line has become 0. So what is the meaning of a key press? One of the column line has 0, 1, 2, 3 has become 0. Now make sure that all the column lines are becoming 1. Whenever all the column lines are becoming 1, that means that no key is pressed. So you should check for that condition. So I will copy that statement. So how do you do it? I will be checking continuously until all the keys are released. So I will put immediately after that this statement. So what I'm doing, I'm indefinitely waiting for all the columns becomes what? 1. That means that if any one of the column is 0, I'll be in the while loop only. See that I've done an OR, logical OR. If any one of the column is 0, still is held by the keyboard, and in the sense still the key is pressed, I'll be in what? In the while loop continuously. You can just, this is nothing but empty. This is empty while loop. So if all the keys becomes 1, that means that this condition is not satisfied. I'll come out of the while loop. So this is what is required to analyze how keyboard program should work. Now look at the program now. So I have identified 4 rows and the 4 columns for the keyboard. What is the logic? Enable the first row, check for the keyboard press in the first row. Then do for the same thing for the next row, and the next row. Each row each time based on the row you are selecting, enable the variable called row select variable. Each time based on the column you identified, so that variable you make it 1. So now everything is ready. The program has been working perfectly. It works. Now I have taken care of the debouncing also. I've taken care of the release of the key also. Now I come here. I want to print the key now. Now, how do I print the key now? What is the information you have now to print the key? I have 2 informations is there. One, I have the the physical location of the key, I know that physical location, the key is indicated by what? Row select variable and column select variable. So that means that I have a two variables, row select and a column select, which give me the physical location of the variable. Physical location means what? If the row select is 1 and the column is equal to column select is 3, that means that what? Oh, this 7 key is the pressed. If row select is equal to 3, if the column select is equal to 2, I know that E is pressed. That means that I have a physical information about the which key you pressed. Forget about the number. Forget about the number. It's very important that number is not important. You got the physical location of the key. Now, to convert the physical location of the key into a proper ASCII code, basically the keyboard is what? Whenever you press a key, the scan keyboard is something, it gives you the ASCII code of the key you pressed. So you want to get an ASCII code of the key. So based on what? The physical location. What ASCII code you should generate for the physical location depends upon the programmer choice. For example, if you press the E key, I can generate the ASCII code for what? Star. I can generate the ASCII code for enter key. Something else I can generate. So it depends upon the programmer what key code he can generate based on the physical location. Now I have taken, now I assume for this program, I have numbered the keys as 0, 0 to F in a contiguous way. So that means that if this key is pressed, I should generate the ASCII code of the E. So now what is the mapping required? Physical location to the ASCII code you have to generate. So whenever you get this type of situations, always you have to use what is called lookup tables. Lookup tables are extensively used in embedded systems to convert the physical locations into what? The ASCII codes. In 7-segment, what was we have done? Lookup table was used to convert what? To convert your ASCII code to 7-segment codes. Yes or no? Now I'm using for what? The physical location I'm using to convert into what? Into the ASCII codes. The other way I'm using it. The purpose is different. Now, since the physical location is described by 2 dimensions, what are the 2 dimensions? Row is 1 dimension, column is on 1 dimension. The lookup table should be what? 2-dimensional here. So now I'm going to create a lookup table. I create a lookup table to map this one. So I will create a lookup table. I will map here. So what is my lookup table here? So look at here. This is my lookup table now. So this is a lookup table I have used. It's a 2-dimensional one. So what I have done? So I have just taken care that. So I've just given like this. So now look at that. The row 0, the row variable row select and the column select exactly enter into the proper place here. If the row select is 0, based on the column select, you will get what? ASCII code of any one of this one. If the based on the row select is 3, you come here. So now if at all, if I don't want F to be printed, I want the star to be printed, then replace F by star. That's all. You can decide what ASCII code to be generated whenever the key is pressed. Now, so now I have created all these things. Now lookup table is ready. Now what should I do here now? I have to convert that into a proper value. So what should I do it? So now I'll take this value. I will take this value. So and convert into this one. So what should I do it now? So the lookup table of row select lookup table. So I'm just selecting the row select and then the column select. So I'm doing it. So I've got the number. So this lookup table now gives me the ASCII code of this one. Where do you display this one? See, there are a number of places you can display. You can display in the port 0. You can display that on the port 0 bit 0.02. So you can display on the 0.7. You can able to do it. Or there is a what is called as a serial terminal is there in the LPC2148. LPC2148 has a UART, that is UART. That means through that you can send the data to a computer terminal also. So here also in the simulator, whatever I am pushing to the UART, I can watch in the serial terminal. Now what I'll do is instead of putting to the port, I can put to the port also. I can send to the port also, or I can able to do that into this also. So I will take the UART now method. So what I'll do is I'll take an UART register. So I will copy that into that register. So we will put to the port also after this. So what is U0THR? mu0 register is a transmitter holding register. That means whatever you write on this register will convert into serial and go out of the LPC2148 on the pins called TXD and RXD. So you can catch them using another terminal which is running on a computer. Now in the simulator, whatever I send on the U0 THR, I can view them using what is called a serial terminal. There is a terminal is there. So there is what is called as the window. We will get it once I go to the debug window. Through that, I can able to watch serial window. I've written that one. But the only thing is, whenever you use U0 THR, lot of initializations you have to do. You have to make the UART ready, the baud rate ready, and everything. Now I'll copy that, the code. So we will learn in the unit 5 how to write that, what is the meaning of that. Now I'll copy that code. Now what I have done here, I'm initializing the UART. I'm initializing the UART. So whatever the initialization, I will invoke that initialization in the beginning of the program. So in the beginning, what I'll do is I will initialize. So why I have done this one? Just to make that UART getting initialized. So where I am putting it, I am just putting it. So initialization code below that. So I will declare a prototype for that. Okay. So now, so what all I have done, just I have used UART in it. So we will learn this in the unit 5 later. So I'm just using one of the register in the UART. So whatever I just write key code, I'm printing in the keyboard. Okay. So only thing I have to take care is, so as we know that whenever we are used at an output pins, we have the direction we have to set it. So I will, before run the simulator, I'll set the direction pin. So I will set the direction pin before I call this. So what are the direction pins I'm setting? FF. FF means, so P0.16, 17, 18, 19. Only one F is required. I just made it FF. Actually, one F is good enough. So I'm setting the 16, 17, 18, 19, the rows as what? Output. So there is no configuration required to make as an input, because by default the pins are input. So I've enabled this one. So now I again compile the program. Okay. So now I'll run the program. So I've already just created some ready things what is required for this program. I have dragged the two peripherals, GPIO1 and the GPIO0 also. 0 we have already used in the previous program. I dragged IO1 also, because why? I'm using port 1, 16, 17, 18, 19 as a columns. If you look at here, so I said that I'm using 16, 17, 18, 19 port 1 as what? Columns. So that is why I'm just dragging this point. I'm observing the what? 16, 17, 18, 19. I'm observing the data here, observing in the columns here. So this is where the 16, 17, 18, 19, I'm generating the output for the rows. I'm generating it. So here I'm just monitoring here. If you look at here, so I just observed port 1, 16, 17, 18, 19. I just plotted here. And the first row to P0.16, I'm just plotting it here. So that means that if by default, all the columns should become what? 1. You can look at here. So P0.16, 17, 18, 19. See that all the lines have become high. That means that when the key is not pressed, this line is always what? High. Only when the key is pressed, this line becomes what? Low. And this line becomes low. Now I'll run the program in a single shot. So now the program is ready. Now what is happening here? You can just look at here. Now this is the pulse generated at the row 0, because I am running this program on a continuous basis. I am running this program on a continuous basis. So whenever I run this program, so you know that what will happen? I'm just making what? 0 here, 0 here. That is mean that I'm generating a pulses here. So make it 0 for some time. Then no key is pressed. Make it 0 for some time here. That is why you are getting a pulses at the row 0. Similarly, if you plot row 1, row 2, row 3, you get these pulses. So you can see that line has been made low for some time and then again. So whenever this has been made low, at that time, if you press a key should be identified here. Now see that all the lines are high. Now how do I simulate a key? How do I simulate a key? There is no keyboard is there with me now. I said no, I've not connected a keyboard. Only way to simulate in the program key is what? physically. That means that you only go there and make this any one of the lines 0. So making any one of the column become 0 manually, that means that a key is pressed in particular column. Like that we will do it. Now what we will do is, so we will go to these lines 16, 17, 18, 19. I physically make some lines is equal to 0 or 1. So I'll make it 0, I'll make it 1. Now you got 3. See, you can just look at the UART, the terminal here. I'll make another 1. So I got, again, I have to make it low, and then what? Because I have to release the key, press the key, release the key. So I got some other some other number. So now what should I do it? So I have just taken the first row. So now to make that effective, because all the rows key cannot be simulated at the same time. Now what I'll do is I will enable the first row and make all the rows. I will make it comment in the program now. I will make the comment. I'll make the comment so that it's easy for me to check. Now the first 3 keys, I'll make the comment. Now only one row I'm selecting it, and see that all the things are correct. Column 0, column select is equal to 0, column select becomes 1, column select is equal to 2, column select is equal to 3, column 3, 0, column 1, column 2, and the column 3. So I have defined columns properly here. So 16, 17, 18, 19. I'll compile the program. So I will run the program now. So I will enable only first row. Now any key press I will identify here also. I will enable here. So now let's say 16, 17, 18, 19. So 19 is correspond to what? The key number 3. So I'll press this. See, you got. I will run the program. Okay. Now I'll press the key. See, now the line has become 0. See, look at that. The line has become 0 now. So other lines are 1, because since I press the line, I press the key, the line has become what? The 0. So which key? The 16th key. 16th line has become 0 because I press the key. Now I release the key. Now you got the 3, because 16 corresponds to what? 3. So the 16 is connected here. This corresponds to key 3. You got the key 3 there. So similarly, you can try for other things. So now the second one, 17 has become low. See that 17, it was high, it is a low. Other things are high. Now I'll again release the key. So, so I should have got that also here, but here it's changing. We will see that. So now 18 has become low, and then again I'll make it 18 high. Okay, then I'll press this one. So it has become low, this point. Again, this becomes high. Okay, so only thing is, so it should be printed here. I should give some delay. I'll give there for the UART, some initialization required there. I'll just give that code there. So just another 2 minutes. So what we'll do is we will give some delay. So delay for the UART after that. So the whole thing I should put in a loop. I will not put in a loop. It's only one time it's printing. So what I'll do is I'll put the whole thing in a while loop here. So this was missing. So what I'll do is I'll put the while whole thing is in loop, so that whole program will continuously work continuously. So okay. So I will just put the whole program in a repeated so that it runs continuously. So what I have done? The whole program I put in a loop so that what will happen? It repeatedly works. Otherwise, it will work for only one time. After that, it's coming out. So okay. While. Okay. Look at here. Now what I've done? The whole program, the do while loop. So which was working fine. After that, it is printing on the screen. That is a terminal, and then it was coming out. Now what I've done? I just put the whole program in the loop so that it repeatedly works. So now I'll go to the terminal here. So run the program. So I'll press this key and release. I got the 3. I'll press this and release. I got a 2. You can see the UR terminal. So I press the 3 and release it. I got a 1. So I press and release. I got a 0. That means that whichever the keys I'm pressing it, I'm simulating the keys by changing this one. I'll get that number in the terminal. So that means that you have developed a program to read from a matrix keyboard and print on the screen. This you can output to the port also. You can send to other terminal. You can read in the program to do something else. You can able to do it. If by chance I want to find out for the other keys, so what should I do it? Now what I'll do is I'll remove the comment here. I'll remove the comment for the one. I'll select other row. So I'll go to the advanced. So uncomment. Okay, should have uncommented anyway. Okay, so now what I'll do is I will just select for another row. I will comment this row. So I selected the row 1 now. So what are the keys I supposed to watch now? So 4, 5, 6, 7 are supposed to get it. So I will compile the program now. So I will run in the debug. So now I'll run the program. So since now I disabled the row 0, I'm not getting the output here. To get that, I have to change that. So now I'll create one more, that is port 0.17. So which I've just added one more row. Okay. So now I'm getting the port 17. I'm generating this row is getting selected by making the 0 pulse. So now I will just check whether keys I'll get or not. So I got 7. So similarly, I'll next. So I got 6. So I got 5. I got 4. That is 4, 5, 6, 7. So these are the keys corresponding to what? The second one. This is how you can develop the complete program and the interfacing logic to design. Now we have developed a complete driver program, and also we have developed complete interfacing circuit. Like this, you can generate any required keyboards in your microcontroller projects and develop the programs for that. So this completes today's session on this one. Any doubts, you can ask me. So I will take attendance and then you can leave it. You can leave. So by chance, any doubts are there?